talk. So you might be familiar if you've done them in the past, but if not, I'm explaining. So I'm gonna put up a couple problems on the screen, one at a time. And you are going to evaluate them mentally. Meaning no scratch work, no calculators, just do the best you can for right now. That way you can be a little bit more fluent in some of those like math facts. Obviously, I would never tell you not to use a calculator any other time. On quizzes test, you should always check your work. But we're just going to see some trends in this math talk right now as a class. When you think you have the answer, you are going to put your thumb up. You're not going to share with your group. You're not going to talk to anyone really. The idea is that there's usually more than one way to solve something, and we can benefit from those other ways. Okay, so I might call in people to share. If you are stuck, that doesn't mean you just get to look somewhere else. You could still be looking at the screen trying to figure it out. So here is the first one. So evaluate that mentally. Don't shout out the answer. Just put your thumb up. We're looking for the mean of that data set. Medina. Okay. Yeah, no worries. Yeah. Bye. We have permission to do that. Okay, so put your thumb up when you think you know what the mean is of 27, 30, and 33. All right, Colton, what'd you get? 30. 30, and how'd you get that? Okay, so in his head, he added up 27, 30, and 33. And then also in his head, he divided by 3 to get 30. I'm guessing it was 90 divided by 3. So not something crazy to add and divide in your head. Did anyone do it a different way to get the same answer? Maybe something we talked about yesterday that might make it even easier to tell the mean without necessarily adding and dividing. If I were to put this on a dot plot, so let's put 27, 28, 29, 30, 31, 32, 33. We have a dot here, a dot there, and a dot there. How would you describe the shape of it? Yes? Okay, uniform. Uniform data is usually also what word? Symmetric. And yesterday we learned that if the data is symmetric, wherever you draw that line of symmetry, the mean is going to be that middle part. So even without doing the math, if you see your data symmetric, the mean will be right in the middle. So maybe that'll help you the next couple if it is also symmetric. Or like we still got the same answer this way, as long as you get the correct mean at the end of the day is all we care about. So now here's the next data set. 61, 71, 81, 91, 101. When you think you know the answer, put your thumb up. If you're looking for the sum. All right, Tristan, what'd you get?
81.
And how'd you get that?
I looked at the middle number. It's symmetric.
Okay, the data is evenly spread out. Each data point is 10 away from the other, so using what we learned yesterday and kind of what we talked about in this one. If the data is symmetric, then the mean is in the middle. I mean, these numbers aren't as easy to add up, but you definitely could, like, it's not impossible either without a calculator. And then if I did add them up, what would I have to divide by?
5.
5, because there was 5 data points. So then when I do that, I do get that the mean is 81. So again, there's multiple ways to determine the mean. But if the data is symmetric, the mean will be in the middle. All right. Next data set, when you think you know the mean, put your thumb up. So 0, 100, 100, 100, 100. Okay, Emerlyn, what'd you get? Oh, 100. Okay. Anyone get something other than 100? Fulton? You take 200? Anyone get something other than those? Over here, sorry, I don't know your name. 75. Anyone get something other than that? Avery? Anyone get something other than that? Now, when I was looking around for thumbs, I only saw like a couple of thumbs to make sure that our thumb, well, we think we know it. Now, mean and median, but we're talking about mean right now, tells us a measure of center, so like a typical value in the data. There's things it can be and it cannot be, and that I can tell you without even doing the math. For my mean to be 100, all these data points would have to be 100. Because we have one that is not, it pulls the actual mean in that direction, okay? So because 0 is smaller than the rest of the data, it'll make my mean smaller by default. So it definitely can't be 100. Can it be 200? Because the mean is supposed to be what all of the data is near, so it can't be 200 either. These two are more reasonable guesses. Is this data symmetric? It is not. So if I were to put it on a dot plot, I'd have 0 here, 100 way over here. I have one data point at 0 and 4 at 100. How would you describe that shape? Yes?
Not smooth.
Less skewed, good. That outlier, if you will, pulls the data or pulls the mean in that direction. So that's why we can't use what we used in the other two, that it's like in the middle of your data, because it's not symmetric. So in that case, you would have to do the math, and these numbers really aren't too bad. 100, well, 0 plus 100 plus 100 plus 100 plus 100 is what?
4.
And 400, to find the mean, I would have to divide by 5. And 400 divided by 5 is 8. So this is 90. So again, when in doubt, do the math. But you can only tell the mean right off the bat if it's symmetric. Yes? I thought the 0 was important. That
Like-
was like,
like the letter D, I
Oh.
can't see.
okay. No worries, I don't have it on your paper this time, because it's really just supposed to be on the screen, but I can see why now. That we got that. All right, last one for the warm up. When you think you have the mean for 0, 5, 6, 7, 12, put your thumb up. Think you know the mean for that. Juliet, what'd you get? Or sorry, is it Juliet? Hold on. No, it is not. Jordan, what'd you get? 6. 6. Anyone get something other than 6? Okay. So how'd you get 6, Jordan? Okay, and these numbers are reasonable to add without a calculator. If I was the one adding, I'd probably combine 5 and 6, 11 plus 12 is 23, plus 7 is 30 in that order, but however way, add them up. And I'd have to divide by what? So 30 divided by 5 is 6. Did anyone get it without doing that? Yes, over here. The data is symmetric, so you also could have just looked in the middle. And that would be your mean as well. So if you're like, what, it's not symmetric, let me show you. How many numbers are 0 and 5 like spaced out? Oh, I mean like on a number line when I say that. So 0 is 5 away from 5, right? How far is 5 from 6? How far is 6 from 7? How far is 7 from 12? 5. So if I did put it on a dot plot, it would be evenly spaced out with 6 being in the middle. So then by default, that would be my mean. But like always, you could do the math, and as long as you get the right answer at the end of the day, it's all we care about. So any questions on that? All right. We are doing lesson 11 today, and just because of the assembly, you know, classes are 10 minutes shorter than they usually are, so it might feel a little bit rushed. But a lot of the same skills we revisit in the next lesson, so that's why I always just keep it moving no matter how far we get. As long as by the end of the unit, you can arrange data sets in order of variability given graphs. That's what you're gonna be assessed on. So variability is like how spread out data is. Lately, we've been talking about mean and median, which tells us like center, so what our data is clustered around. Variability tells us how spread out our data is. So like IQR, MAD, and standard deviation are all measures of variability. They have nothing to do with mean or median. I'm recording right now. I always link it. Should you want maybe a longer lesson, maybe more examples? I think last year we didn't have an assembly the day I taught this, so you could go watch that if you want to. The puzzle piece is lesson 11. You always have a practice, even if I don't explicitly tell you, it's usually in school and you can see it really easy. And we do have a quiz today, so that's why at maybe 10:45, we will stop and take the quiz. It's timed for 25 minutes, so should you want to like stay and finish it, like if class ends before your timer runs out, you can. You certainly couldn't take it like at lunch or in another class. So it's just, if you want to stay, I can write you a pass. If not, I could probably open it on Monday, but I'm gonna be watching for if it's not done and all that stuff. We're just gonna keep it moving to get as much as we can done from the activity today. So in your baskets, you should find maybe 1 or 2 sets of cards, depending on. Some groups have 2. If you have 2 sets, you could split your group up. If you have 1 set, then just work together. What you will be doing is matching the graph to the summary statistics. So it might have like the shape on there. It might have the mean or the IQR. You are going to match the description to one of the graphs. Take turns, don't be a hog, don't be a log, make sure everyone matches at least one. And then because it really shouldn't take crazy long and we're also kind of in a rush, I'm gonna time you for 3 minutes. 3 minutes. Right, in 3 minutes, we're gonna go over the answers, so we'll have your best guesses in by the 3 minutes. 30 minutes. Here are the matches. We'll kind of start with A, B, C, D, like in that order. So data set A goes with description I. Because that data is symmetric. Meaning that you can easily tell the mean. It could be where you would draw the line of symmetry down the middle. And that mean is 6. Something we briefly talked about yesterday, but just barely, we're gonna like, I don't know what the word is, focus on today. When the data is symmetric, what is better to use to describe it, mean or median? Mean, actually. So make a note, use mean because it's symmetric. And I mean, the mean will match the median, but that's just like a test question. When the data is symmetric, use the mean. Now for measures of spread, do you think I should use IQR, standard deviation, or MAP? Which one most closely goes with the mean? Do I need the mean to find IQR? No, for IQR, I need Q3 and Q1, right? So I do need the mean to find standard deviations. I also need the mean to find the MAP. So whenever the data is symmetric, we prefer the mean, standard deviation, and the MAP to describe it. To start like knowing moving forward. Questions so far? Okay. So in data set B, that one should have been matched to description L. Would you say this data is symmetric? When it is symmetric, you will use the mean or median. This needs to be like fast recall. I already told you multiple times. Do I use the mean or median when it's symmetric? Mean. When I use the mean to describe it, will I use IQR, standard deviation, or MAP? MAD stands for mean absolute deviation, so they should go together. What else uses the mean? For those of you that we talked about it just a second ago. Look at the other one. What one do we also use? Standard deviation. What do you know? All right, next one. Data set C. Does that data look symmetric? If I were to draw a line of symmetry down the middle, Does it look like a mirror image on both sides? Not perfectly. Oh, from here to here, it is more spread out. Therefore, when it is not symmetric, what should we use? The mean or median? So we use the median. For measuring how spread out it is, should we use the IQR, standard deviation, or MAP? IQR. You see how the mean is -14, but my middle, where my line of symmetry would be, is not -14? That is why we don't want to use the mean. Or to use the median, makes sense? But the mean you actually have to calculate versus the median that's more like representative and that's actually in the middle. All right, and that went with data set or description N, by the way. To keep track. Up at the top, data set D. That description best went with M, where it is skewed right, and the median is 11. So when it is skewed, should I use the mean or median? Is skewed symmetric? No. So then I should use mean or median? Median. And then should I use IQR, MAD, or standard deviation? IQR. Yesterday, we talked about what outliers do. And they pull the mean in that direction. So, I mean, it's not perfectly symmetric. We'd actually have to do the math to calculate the mean. That is why we prefer to use the median to be more representative of the data. All right, now histogram E. Best went with the description J. It is the only one that is skewed left. So that means that this data is pulling the mean in that direction. So even though most of the data is like from here to here, this pulls it down. So should I use the mean or median? If you're more than one person, is it symmetric? So should I use the mean or median? And then for how spread out it is, should I use IQR, standard deviation, or MAP? IQR. All right, almost done. Now we have our box plots. So box plot F, would you say that that is symmetric? Could I draw a line of symmetry somewhere and it look like a mirror image on both sides? So it is symmetric. What would be better to use then, mean or median? So use mean. And then because it's symmetric, should I use standard deviation, MAD, or IQR? Standard deviation and MAD. So even though it's a box plot, that doesn't mean you always use the median. It told you the median so that you can match it easy. But yeah, the mean is going to be in the middle because it's symmetric. Last one, box plot G must go with description H. This is what it looks like when a box plot is skewed to the right. This 25% of the data is more spread out. Should I use, or let me ask you this first, is it symmetric? No, it is skewed. Therefore, we should use the mean or median. Median. And then for variability, should we use IQR, standard deviation, or MAD? IQR. That needs to be maybe like something you make a flashcard for. It should just be very easy, like if it's a metric, use the mean. And that is standard deviation. If it's not, use the median and IQR to describe it better. We're gonna stop now and take the quiz. So I'm gonna put the password up on the screen. I'm gonna